So let me share the file. Yeah. So today we are going to discuss the mechanics. As we discussed yesterday, uh, laws of motion, I guess, right? Okay, right. Let me check it. Right. Did you fill the attendance, guys? Student, are you able to see the link?
Yes,
Yes,
sir.
sir.
So did you fill it?
Yes, sir.
Sir.
No, sir.
Yeah, but it's important. You have to fill that.
Send link, sir.
I think I did it. Let me share again. I'm gonna call the names now. Let me. What is that? I cannot. I can see only 20 members today. I don't know why. Yeah, I think. Are you able to see the link?
Yes, sir.
I just fill it, and I have a list of students who have joined. Let me call that. Before that, I wanna stop this. I don't want to just stop it. Okay. Yeah. Good morning again. Welcome to mechanics class, BSc first year. I'm going to. So yesterday we were, discussing. I think, yeah, we stopped. We didn't. Did we discuss the momentum? No, right? Yeah, we just completed the first law. Anyway, yeah. Let me start the. So we, as you all know, that we have started yesterday first law, right? uh, which is very important for mechanics, right? I mean, it's very important for physics too. So you have to be careful. So you have to understand these laws. So Newton laws are very important. Uh, so what they tell? The first law we already discussed it, right? First law, it states that every body, every object continue its state of rest or a state of motion until and unless an external force is applied. So that is what we have discussed, and also we mentioned that according to physics, it's like inertia law, or inertia is a kind of laziness. So we have discussed this, and moving forward to the uh, we completed this. Coming to momentum, what is the momentum? It's very important. So, what is the momentum? Tell me. So, momentum is it's a very important concept. So, we indicate with the P is equal mv, right? What is that? Momentum definitely require two quantities. What are this? Mass and velocity. If I want to tell the momentum of any object, I should just simply multiply the mass and velocity. So when two stones of different masses, you can see this is a very important example. So when you're dropping two objects, different masses from certain height, let's say these are the height, okay, which will cause the greater damage. So I have a big mass here, I have a small mass here. I just dropped it on the ground. So which will damage more? So for that question, the stone of larger mass dropped from the greater height causes the greater damage. Why? Because when you're dropping an object from certain height, so that could be, it's just product of mass and velocity, right? So if the heavier body, definitely, it's greater damage. You're dropping the object from the larger height. Height is larger and the mass is higher. Definitely, the damage should be higher. So here you can see clearly that stone of a larger mass, which means mass is higher, drop from the greater height, the height is higher, can cause the greater damage. So that means it's a product of the mass and velocity. We call it as a, what do you call it? Linear momentum. What is that? Linear momentum. So now you understand. If I drop two objects with the same height, okay, one is the larger mass, the other one is smaller mass, and heights are same, which object reach the ground the same time, or does it, if I consider the no air friction or air resistance, so which one falls the first? Both will reach the ground same time. If I do not consider the air resistance, let's say air is not there, so definitely both objects reach the same time. But if air is there, definitely it causes the resistance on the body, and there are different issues that are there. There's different cases are there. But one thing you should remember: if I give the larger momentum, definitely you go faster. If I give the little push, you don't go the faster. So remember that momentum is simply, it's a product of the, you should note down all the point. Don't I'm not going to send any notes again, okay? You should write your notes. So that is, you have to remember. Some people are asking, some students are asking, send the notes. See guys, we are in the graduation, undergraduation, right? So it's your responsibility to note down the points. It's not like a school to give the gain. Momentum is the product of mass and velocity. No, you should start writing it, right? So whatever the, I send the YouTube links are there. So YouTube everywhere, you can access it many times till you understand perfectly. And I'm also sending the PPT files where you can get the copy the notes. So a lot of ways the technology developed. Don't depend on the olden days. Write down momentum is mass times velocity. M is a mass, velocity is a v, p is equal to mv. So you don't want to waste time like that. It's your response. Just speed up. Okay, we have to upgrade ourselves and learn a lot of things instead of wasting the time for just getting the ABC notes. Okay, so here, so momentum of the body, what is the definition, beta? It's just a product of mass and velocity. The quantity motion contained in it. When I say momentum means it's a quantity of motion. How fast you go is the momentum. It's a product of mass and velocity. So P is equals to mv. So it is denoted by the P, and m is the mass, v is the velocity, and you can see here kg meter per second units. Kg meter per second. Momentum units are mass is kg, velocity is meter per second. So kg meter per second. So I'm just revising stuff. These are intermediate questions, right? So moving forward, did you copy? Did you copy?
Yes, sir.
Yes, sir.
Yes, sir.
So moving to the next slide. Newton's second law, you can now, when I completed the momentum, I can talk about the Newton's second law. So F is equal to dP by dt. F is equal to dP by dt is my second law. If someone asks you, what is second law? It just simply this. Second law definitely talks about the force beta. Second law talks about the force. What is the definition of force? Is the rate of change of momentum. So how linear momentum is changing with respect to time. That gives the force definition. So from here, we already know that momentum d by dt, p is actually what? ma. Sorry. P is what? mv, right? So when I write it that m is a constant, it doesn't change. M dv by dt. So where dv by dt is what? Velocity, rate of change of velocity is acceleration. So we can get from here is F is equal to ma. This is the derivation for second law. So force is what? It's a rate of change of momentum with respect to time beta. So how momentum is changing with respect to time? So that is dp by dt. So but we already know that p is equal to mv. So when I substitute here mv, m is a constant which does not change with time with respect to time. So m dv by dt, you can pull it out. By తీసుకొస్తే dv by dt అవుతుంది. ఆ dv by dt ని ఏం రాయొచ్చు? ఇక్కడ మనకు వెలాసిటీ ఏమంటారు? ఇది యాక్సిలరేషన్ అవుతుంది. రేట్ ఆఫ్ చేంజ్ ఆఫ్ వెలాసిటీ ఇస్ ది యాక్సిలరేషన్. So now we got it, F is equal to ma derivation also, right? So here, according to first law, we already know that no force. In the first law, we don't talk about the force because if you apply the force, it changes the. So a body should be at rest or it should be in the uniform motion until and unless you apply the external force. But if there is a force, we talk about the second law. సో ఇఫ్ నో నెట్ ఎక్స్టర్నల్ ఫోర్స్ యాక్ట్ ఆన్ ద బాడీ, మొమెంటం కాన్స్టెంట్ గా ఉంటుంది. దీని మీద ఫోర్సే లేదంటే ఏమవుతుంది? సో కంప్లీట్లీ డిపి బై డిటి జీరో అవుతుంది. ఇట్స్ డిపి బై డిటి ఈక్వల్ టు జీరో. ఇఫ్ దిస్ ఈజ్ ఈక్వల్ టు జీరో, డిపి ఈజ్ ఈక్వల్ టు జీరో. ఇఫ్ దిస్ ఈజ్ ఈక్వల్ టు జీరో, పి ఈజ్ కాన్స్టెంట్. So when external force is zero on the system, its momentum is constant. Because force zero means dp by dt zero. Cross multiply dp equal to zero. dp zero, momentum is zero. So there is no external force. There is no external force on the body. Its momentum is equal to constant. Hence, when the momentum of the body changes, ఎప్పుడు momentum అయితే చేంజ్ అవుతుందంటే ఏంది? ఫోర్స్ అప్లై అవుతుంది. When there is a momentum change, dp by dt, there is a force. Body must under the action of external force. So when there is a force, there is a momentum change. So according to that, this is the second law. The rate of change of momentum of the body is directly proportional to the net external force acting on the body that takes place in the direction in which the force acts. దాని మీనింగ్ ఏంది? మూమెంటం అంటే మూమెంటం ఏ విధంగా చేంజ్ అవుతుంది అంటే రేఖీయ ద్రవ్యవేగంలో మార్పు రేట్నే ఫోర్స్ అంటారు. ఫోర్సు ఏ డైరెక్షన్ లో అప్లై అవుతుందో ఆ మూమెంటం కూడా అదే డైరెక్షన్ లో ఉంటుంది. సో రేట్ ఆఫ్ చేంజ్ ఆఫ్ మూమెంటం సో యాక్ట్ ఇన్ ద సేమ్ డైరెక్షన్ ఆఫ్ ది ఫోర్స్. సో డెఫినేషన్ ఆఫ్ సెకండ్ లా, so the rate of change of momentum of the body is directly proportional, అంటే same, it's like this, directly proportional to the net external force acting on the body. Okay, so that's what I think you understand the second law also now. So can I any doubts please?
అన్నా నేను కొడతా, నా కొట్టి చూపిస్తా అన్నా. ఏందన్నా ప్లీజ్ అన్నా.
Okay. So it's your responsibility to mute when something is noise going on in your home. You just mute it. Okay. Right. So I think, can I move further next slide? I think it's clear.
Yes, sir.
Second law is clear. So second law, I just gave some example, but it doesn't, you don't need it. Yeah, I mean, as I mentioned, it rate of change of momentum of body, it's directly proportional applied force. So direction should be same direction of the force. So, like, when you apply the force on the ball, definitely it changes its direction. So it talks about the, kind of like if you apply a force on the wall, definitely there is amount of same amount should be. From here only we'll move further third law. Okay. The second law of motion tells us there is a net external force on the body. సో సెకండ్ లాకి థర్డ్ లాకి డిఫరెన్స్ ఏమొస్తుందంటే ఇక్కడ నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఉంటుంది. నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఈజ్ దేర్, బట్ హియర్ నో. యాక్షన్ రియాక్షన్ సేమ్ అవుతాయి ఇక్కడ. ఓకే, హియర్ దెర్ ఇస్ ఎ నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఉంటుంది కాబట్టి ఒక డైరెక్షన్ లో బాడీ మూవ్ అవుతుంది. వెరస్ హియర్ ఇట్ డజంట్, ఇట్ జస్ట్ హిట్ ద వాల్ అండ్ ఇట్ అగైన్ ఇట్ హిట్ బ్యాక్ యూ. యాక్షన్ రియాక్షన్ ఫోర్స్ ఆర్ ఈక్వల్. Your second law, always there is a net force ఉంటుంది కాబట్టి it moves in a particular direction, the resultant force direction. Okay, so that is the difference, you have to remember it. Don't tell same, both are same. My definition still it's so you already know this. This is the most important formula for Newton law. F is equal to ma, mass into acceleration. And you already know that this is also very important. Conservation of momentum. What is the conservation of momentum? Tell me. Conservation of momentum. So conservation of momentum is P should be constant and F is equal to 0. This is what conservation of momentum. If the net external force acting on the system is 0, if the net force acting on the system is 0, its momentum is constant. This is called conservation of linear momentum. Conservation of linear momentum. So can you, suppose if someone asks you, can you state the conservation of linear momentum? Yes, sir. When there is a force acting on the system is 0, its momentum 0, its momentum is constant, sir. Why? Because F is equal to 0 means it's a dp by dt is equal to 0, sir. So when this is equal to 0, dp is equal to 0, sir, then p is constant. This is what you have to prove it. If someone asks you conservation of linear momentum, you should define it first and write these two steps. Okay, so if there is no external force acting on the system, its momentum is constant or momentum change is 0. Momentum change 0 అవుతుంది, momentum constant అవుతుంది. Simply you can see better. The ball is bouncing on the surface. What happened? It's coming this direction, bouncing back. So if you are considering this is a positive axis, positive direction, this is the negative direction. So in this case, what happened? Tell me. White V2 P2 minus P1. So the change in linear momentum of particle should be what? Final d momentum is dmv, initial momentum is mv. So let us say v is same velocity, initial and final velocity is same. So minus mv. So final velocity, final momentum is mv minus of minus mv, which is going to be 2mv. Which is going to be 2mv. So you should know this. Change in momentum, when someone says change in momentum, final momentum minus initial momentum. Final momentum is mv, sir. Initial momentum also mv, sir. So but I mean minus into minus plus 2mv. And this is also very important bit for the competitive exams. After BSc, you're going to attempt a lot of competitive exams, IITs, MSc, Central Universities, a lot of exams are there, NITs. So you should remember all this stuff. So this is positive direction I'm taking, this is negative. You should always take this like that. Okay, I'm clearing this also. Okay, derivation I don't want to repeat. This is same already. I will complete F equal MA. I don't want to do this. Impulse is also important, but I don't want to. I just want to revise it. This is intermediate itself. What is impulse? Impulse is kind of like when you're jumping on the building. Suppose you are jumping from the building to the on the sand and rough surface, concrete road and the sand. So where in which case the person get more hurt when he jump on the concrete road. When he jump on the sand, he doesn't get hurt. Why? Because there is a impulse less. Here impulse is less compared to the hard surface. So what is the equation? Tell me. Impulse is the product of the force and time. Impulse is the product of force and time. If the time increases, force will decrease. Like catching a ball. So you guys are playing the cricket. What does the bowler do? He just catch the ball. He can't hold his hand like that. He just pull it like this. What he's doing is he just increasing the time to decrease the force. This is what impulse. Or when you're jumping from the building to the sand, you are jumping into the sand means you are increasing the time for to decrease the force, impulse force. So these are the examples. Like when you're catching ball, only people increase the time to decrease the force. So impulse is the product of the force and time, and you can Newton second is the units, okay, and Newton second, and you can also write down the dimension formula, but we are not going to discuss that here. SI units, Newton second, Diane second is the CGS. Impulse is a vector quantity because J is a vector, force is a vector. So impulse is a vector quantity whose direction always along the force direction. Okay. So over application of yeah, these are the also you can also I'm these are the kind of concepts I'm teaching now, and you may not see these questions in the exams, but these are very important to apply. So impulse, you already know this, concrete road, I already explained. A person falling on the concrete floor from certain height receive more injuries when a person falls same height on the loose side. Loose side మీద పడితే దెబ్బ తలగదు, కాంక్రీట్ రోడ్ మీద పడితే దెబ్బ తలుగుతుంది. ఎందుకంటే అక్కడ టైం డిక్రీజ్ అవుతుంది, ఇంపల్స్ ఫోర్స్ ఎక్కువ అవుతుంది. ఇక్కడ ఈ డిక్రీజెస్ ఇంక్రీజెస్ టైం, డిక్రీజెస్ ద ఫోర్స్. అలాగే breakable articles like China ware, television sets are transported from one place to another place by packing them in the felt or soap foam లలో పెట్టి మనము గ్లాస్ ఐటమ్ ని ట్రాన్స్పోర్ట్ చేస్తాం. when you want to shift your house from one place to other place, what do? You keep everything in the glass items in a foam కానీ లేకపోతే పేపర్స్ కానీ పెడతాం. ఎందుకు? they don't want to break. సో వై ద ఇంపల్స్ షుడ్ బి, అంటే మూమెంట్ వచ్చినప్పుడు ఇంపల్స్ తక్కువ అవుతుంది, టైం ఇంక్రీజ్ అవుతుంది, సో ఫోర్స్ తక్కువ అవుతుంది, పగిలిపో. సో దే డోంట్ బ్రేక్ ఇట్. Similarly, shock absorbers are used in vehicles to reduce the magnitude of impulse force. Bikes, if you see the bikes, they keep the rods in front of the bike, and they keep some liquid inside. And what they do is whenever the bike sees, whenever you see the speed breakers, the bike should not get a damage, because the shock absorbers can take the more time to apply the force. So it's kind of like they move up and down. In that case, what happened? They increase the time to decrease the force. Cricketer also lower his hands while catching the ball to reduce the impulsive force. All these are the impulse examples. I'm just going fast. I don't want to. Third law. So Newton's third law. So to every action there is a equal and opposite reaction. That is called third law. So second law we completed, impulse we completed, momentum we completed. Momentum, impulse are close to the second law. So why we completed? So first law we don't see any force. Second law we see the force. When you see the force, momentum changes. So momentum also completed. Impulse also momentum is involving. So conservation of momentum also, like force is zero means momentum is constant. So we discuss the conservation of momentum too. So Newton third law, again it involving the force. So to every action there is equal and opposite reaction is there. That is called Newton's third law. For every action there is a equal and opposite. Remember guys, keep in the brain. So every action there is a always equal and opposite reaction is there. So when you push object, it pushes back, right? Like you can see here also. So what is going on here? The boat. So basically you paddle is there. Just keep it forward. They pushes the water backward, and which will help to move the boat to forward direction. So the same thing, action reaction for there, right? So not only this, load of applications there. When you hit the uh, when you hit your hand, like you take the apply a force on the wall also apply on the force, same amount of force. If there is a resultant force, you can move in that direction. If there is no resultant force, whatever force you apply, the same amount of force apply on you. But here you have to remember that these two forces are not acting the same surface. So you are applying the force on the wall and the wall is applying on you. So both are different surfaces. So they do not be same. So you have to remember here that people ask you, do the action and reaction force apply in the same surface? No, they apply in the different surfaces. Okay. So I think time is running. I think we are close, almost like a, 15. But yeah, I have some questions here for bit type. What is the common factor in which you describe the system where the Newton's laws are applicable? Definitely acceleration should be there, right? What is the common factor in which describe the system condition where the Newton laws are applicable? Acceleration play a very important role. And free body diagrams comes like again action reaction. So I don't think we don't have this is like intermediate, so I don't want to, I mean I can give some idea of free body diagram. What is free body diagram? So what is free body diagram? Free body, so you have the object. What are the, this is the mass of object, what are the forces acting on the system is called free body diagram. Okay, free from anything. So when someone asks you, can you write down the free body diagram? Which means you have to indicate the forces acting on the system. So suppose you are taking the gravitational force acting downwards. If something is, you are hanging this mass, the tension force is acting upward. Okay. So you are stretching, this is a spring, you are attaching the block of it, and the gravitational force should be downwards and tension should be upward. So simple, you don't draw all this stuff. So you should simply draw this free body in terms of free body diagram, mg and tang. And which one is more? It depends. Suppose if the block is going downwards, f is equal to mg minus t. If the block is going upward, F is equal to T minus mg. Depend upon the which force is acting more, that direction you should take first. Mg minus T or T minus mg. I'm going a little faster. None of these are the basic. I don't want to, all the same thing better. You can see here, if the system is pulled upward, remember, with the acceleration A, the tension in the string is T. So now we are talking about pulled upward and it's going upward. పైకి వెళ్తుంది. పైకి వెళ్తున్నప్పుడు ఏంటి? రిజల్టెంట్ ఫోర్స్ పైకి ఉంది. అంటే MA అనేది పైకి వెళ్తుంది. Acceleration. So downward force, this is a free body diagram. So when I say free body diagram, now downward force is mg, tension always upward force, but the system is going upward. So again another force is also there, F, resultant force also upward. So now we should write simply T plus F, or T plus upward force must be. So no, you can write it like F is equal to, or MA is equal to, so T minus mg, right? T minus, it's going upward, T minus mg, or you can also write it as a T is equal to ma plus mg, or you can take common a plus g. See, this is what equation is. So remember that if the body is moving upward, you should write it like T minus mg is equal to this. If the body is moving downwards, in that case, mg minus t, mg minus t is equal to ma. T should be equal to mg minus a. All this is very basic, MSET IIT problems, but we are not doing that now. So I don't want to spend on this. But anyway, these are the kind of basics that I want to. A lot of questions are there. I don't want to spend on this. We don't need these actually. Law of conservation of linear momentum is already completed. In the absence of external force, linear momentum of particle or body remain constant, which are already completed. Yeah, these are all I don't need actually. Yeah, friction. No, actually, we don't have that topic, but let me give that. Friction is a property which always opposes the relative motion between the body in contact and acting tangentially to the surface in contact. So, what is the friction force? Friction force is always oppose the relative motion of the body in contact. అంటే మనం ఏదైనా సర్ఫేస్ పైన ఉన్నామంటే డెఫినెట్గా యువర్ వాకింగ్, ఇఫ్ దెర్ ఇస్ నో ఫ్రిక్షన్ యూ కాంట్ ఈవెన్ వాక్ ఆన్ ది సర్ఫేస్. మనం ఫ్రిక్షన్ ఫోర్స్ లేకపోతే మనము నడవలేము. ఓకే, సో ఫ్రిక్షన్ ఫోర్స్ ఆల్వేస్ సారీ opposing force which comes into play tangentially between the two surfaces. ఎప్పుడైతే మనం నడుస్తూ ఉంటామో there is a force between this surface and body which we call is friction force, which always opposite direction to the motion of the body. సో ఫ్రిక్షన్ ఫోర్స్ ఎప్పుడు కూడా మనకు మోషన్, బాడీ యొక్క మోషన్ ఉన్న డైరెక్షన్కి ఆపోజిట్ డైరెక్షన్లో ఉంటుంది. అది ఎప్పుడు కూడా అపోజ్ చేస్తుంది. సో ఐ థింక్ టుడే, so I don't want to spend this, I don't want to go depth of all this stuff because we don't have this syllabus. We have to go for the next topic is uh, the rocket motion. So rocket motion, we have a long answer equation for the rocket motion. So we're going to discuss in next class rocket motion and multi-stage rocket, how the rocket goes into the space with a multiple steps. First, what is how much fuel we have to kill, all the stuff we are going to do it, and these are the kind of basics for that. That is the reason I started all the laws of motion. But laws of motion we have first law, second law, third law. The basics are there. Maybe they may ask you for the 4 marks question, but not long answer. Okay, I'm stopping now today. I think but the strength is very less. I don't want this. I want definitely it should be more than 50, because we are almost reaching for the we are reaching for the almost 50% syllabus. After this unit, almost 50% syllabus will complete. So be careful, tell your friends. And I also posted the list of the students, so you can check your names, if and tell your friends. If you see any one of you, forward this, it's very important. So